Hello, 1301 class. Thanks for coming. I want you to join me today as we look at rules for determining oxidation states of elements. And it's a review because you've already had it, but I just want to make sure that you can do it again, and it never hurts to get our memory refocused and refreshed and review some concepts that we've had in the past. So let's get started. Rules for determining oxidations. Oxidation numbers. Okay? First rule is the oxidation states for elements in salts that are the metals, group 1A and 2A, is always +1 and +2 respectively. So group 1A metals, +1. Group 2A metals, when they are in compounds such as salts, metal plus a nonmetal, always +2. Always. You can rely on those. This is the alkaline metals. These are the alkaline earth metals. What I did when I was a student in my periodic table, where I had these columns, I put a +1 here and a +2 here. These are the first two columns that start off the periodic table. So I always knew whenever I saw a compound that contained a metal with a nonmetal, obviously the metal gives up its electrons and becomes positively charged. What is that charge? It's always the same. Now you have to be careful with hydrogen. So hydrogen is always +1, except when with a metal. And then it's -1. Give you two examples. HCl. Okay? HCl. Chlorine is -1. This has to equal 0. That makes the hydrogen +1. +1 plus -1 equals 0. Let's look at sodium hydride. Sodium hydride. Sodium, group 1 metal, +1. Charge on this guy is 0 because it's a neutral molecule, +1, plus hydrogen is -1, total charge 0. Okay? So be careful when you see hydrogen with a metal, that oxidation state is no longer going to be positive, it's going to be negative. Okay? The next rule. Now, one other caveat for this. Excuse me, Krause is barking at the lady down the hall, and hopefully she won't call the campus security on us. Krause, stop that. Krause, no. Okay, so anyway, one caveat, don't forget this is elemental hydrogen. The oxidation state here is 0, which brings us to our fourth rule. Oxidation states for elements in their elemental form. That means their readily available form in nature. How do they exist in nature? Equals 0. So for instance, sulfur. Sulfur exists in nature as S8 often. And so each one of these sulfurs has an oxidation state. That's each one of 0. Hydrogen, all the diatomic gases, each hydrogen has 0. Each oxygen has 0 oxidation state. Each fluorine has 0 oxidation state. Each chlorine has 0 oxidation state. What if I look at a metal in its solid form? Not reacted with a nonmetal. This is alone. You go to the Earth's core, and you dig down deep and you get a little bit of magnesium or calcium metal, that oxidation state is 0. You'll see an S at the end, and that'll tell you oxidation state 0. So elements in its elemental form, that means its readily available form in nature, is 0. The next thing we want to think about is the nonmetals. Let's look on the right side of the periodic table. Okay? So group 7A, I call 7A, some periodic tables say 17. I don't know what number I'm on. I think I'm on 5. If I'm not, change it. Let me get some black so we can do black a little better. And black will show up a little better, I believe. So group 7A, the chalcogens. When in a formula with a metal, this is an ionic compound, the chalcogens are always -1, except when they're with oxygen or themselves. And they can be positive. So you need to be very careful with that. I use those when I don't have sodium, when I don't have group 1 and 2, I'll go to the halogens. But when I see a halogen with a chlorine, or one halogen with another, or a halogen with an oxygen, I hold off, I look at the oxygen first, and then I'll come back to the halogen. Okay? So group 7A always -1. Group 6A, these are the chalcogens. Usually, let's put usually -2. Again, these are ones you want to leave till last. And how do I leave that till last? Well, what you want to do is you want to remember that the sum of the oxidation states of a neutral element is always 0. Now, for group 5A, it's usually -3. So what I used to do when I was a student, I ignored the noble gases because they're noble. They like to exist on their own, so they don't really, they do, but for your case, they don't really gain electrons because they have a filled shell. So we'll go on to 7. So what I used to do at 7, I put -1. At 6, I put -2. At 3, I put -3. So here we're looking fluorine, oxygen, nitrogen, if we're on the second row, obviously. Okay, so you can do that, and that'll help you. My advice when you're doing oxidation states, do group 1, group 2, oxygen, hydrogen, then do everything else last. Setting the sum of the oxidation states of a neutral molecule to 0. Krause, if you play with that plug, you're going to end up fried. Okay, the sum of the oxidation states of a neutral molecule to 0. Again, we did that. Let's say we have sodium chloride. This total state equals 0. I'm going to do group 1A first, +1. What is the chlorine? If the total charge has to be 0, it's -1 here. And hopefully that will help you when you're determining oxidation states. Now, the last thing I want to do is say that the sum of the oxidation states of a charged species, whether it's negative or positive, if it's negative it would be an anion, if it's positive it would be a cation. The sum of the oxidation states of a charged species is the charge. So instead of setting it up equal to 0, you're going to set it up equal to the charge. Let me give you an example. I'll erase this and show you real quick. This is a review for you guys. I wanted you to have it to make sure that when you're doing these redox reactions, these oxidation reduction reactions, remember we talked about that last week. When you're doing those, you can determine what the oxidation states are very quickly. Get out from behind that curtain, Kraus. Okay, so now, one more thing. Let's look at this. PO4 3 minus. The phosphate polyatomic anion, total charge minus 3. That's what the sum of these two oxidation states must be. So I'm going to do my oxygen before my phosphorus. I work out, then I come in on the periodic table. I'm assured on those outer columns. As I work inward, I get less sure of those oxidation states. Rule of thumb, out, come inward. -2 times 4, -8. My total charge is -3. Therefore, the oxidation state of the phosphorus must be +5. Okay, so that's how you do determining oxidation states. Those are the rules, and I hope that helps you when you're doing your homework today. And I look forward to seeing you tomorrow. Before I go, let me just tell you that I appreciate you. I appreciate your hard work, and I want to tell you that we're praying for each one of you, that the COVID-19 does not impact your family or your homes or your community. And again, remember, social distancing. Thank you. Have a good day.